Running both 120 volts and 277 volts emergency circuits in the same conduit is generally against electrical code. The main concern is the potential for insulation breakdown and arcing between conductors operating at different voltage levels. This can compromise the integrity of the emergency circuits and pose a significant safety hazard. Electrical codes, like the National Electrical Code, or NEC, provide specific guidelines on voltage separation within conduits to ensure safety and prevent electrical failures. The NEC aims to minimize the risk of faults that could lead to fire, equipment damage, or electrical shock. When considering electrical installations, it is important to follow the guidelines set by regulatory bodies to guarantee a safe and reliable electrical system. Firstly, one should reference NEC Article 300.3. This section addresses the general requirements for wiring methods and materials, including voltage limitations. It states that conductors of different systems shall be wired together unless specifically permitted otherwise. Emergency systems typically fall under different system classifications than general lighting or power circuits. Secondly, consider NEC Article 700. It pertains to emergency systems, which are intended to supply illumination and power essential for safety to life and property in the event of failure of the normal supply. Emergency systems are critical for maintaining essential functions during power outages, such as lighting exit routes and powering fire pumps. Because of their importance, emergency circuits often have more stringent requirements to ensure reliability and prevent failures. Thirdly, another aspect to consider is insulation voltage rating. The conductors used in electrical systems have insulation with specific voltage ratings. For example, conductors rated for 600 volts can safely handle voltages up to 600 volts. If conductors with different voltage ratings are run in the same conduit, the lower voltage rated conductor may be subjected to stresses beyond its design capacity, leading to insulation breakdown. Fourthly, there is the consideration of induced voltages. Running conductors of different voltage levels in close proximity can induce voltages in the lower voltage conductors. This induced voltage can interfere with the proper operation of sensitive electronic equipment connected to the 120-volt circuit. It could also pose a shock hazard if the induced voltage reaches a dangerous level. Fifthly, conduit fill calculations should be done. The NEC specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. This is known as the conduit fill. Running too many conductors in a conduit can lead to overheating and insulation damage. When conductors of different sizes are run together, the conduit fill calculations become even more critical to ensure that the conductors are adequately cooled. Sixthly, the physical separation between conductors is something to consider. In some cases, the NEC may permit conductors of different systems to be run in the same raceway if they are physically separated by a barrier or divider. This barrier must be made of a non-conductive material and be securely fastened in place. The purpose of the barrier is to prevent accidental contact between the conductors and to provide additional insulation. Seventhly, the use of different wiring methods should be considered. Instead of running both circuits in the same conduit, one might use separate conduits for the 120 volts and 277 volt circuits. This provides complete isolation between the two systems and eliminates the risk of insulation breakdown and induced voltages. Other wiring methods, such as cable trays or wireways, can also be used to separate the circuits. Eighthly, consider specific exceptions in the NEC. There may be specific exceptions to the general rule prohibiting the mixing of voltages in the same conduit. For example, the NEC may permit control circuits operating at different voltages to be run together under certain conditions. However, these exceptions are typically very limited and require careful evaluation to ensure compliance with all applicable requirements. Ninthly, local amendments and regulations should be taken into account. Local jurisdictions may have amendments or regulations that are more restrictive than the NEC. It is important to check with the local electrical inspector to determine if there are any specific requirements in the area. These local rules may address unique conditions or concerns specific to the region. Tenthly, always prioritize safety. Ultimately, the decision of whether or not to run 120 volts and 277 volt circuits in the same conduit should be based on safety considerations. If there is any doubt about whether the installation will comply with the NEC and other applicable regulations, it is best to err on the side of caution and run the circuits in separate conduits. For example, NEC Table 310.15. V16 provides ampacity correction factors for conductors and raceways exposed to different ambient temperatures. If conductors are bundled together, the heat generated can cause the insulation to degrade more quickly. It is essential to follow manufacturers' recommendations and directing factors to prevent overheating and insulation failure. In addition to voltage separation, there are other factors to consider when designing and installing emergency electrical systems. One is the sizing of conductors. The conductors must be sized to carry the full load of the emergency equipment they serve. Undersized conductors can overheat and cause voltage drop, which can impair the performance of the emergency equipment. The NEC provides tables and formulas for calculating conductor sizes based on the load current and the length of the circuit. Another factor to consider is the overcurrent protection. Emergency circuits must be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from overloads and short circuits. The overcurrent devices must be sized to protect the conductors and the emergency equipment they serve. The NEC provides guidelines for selecting the appropriate overcurrent devices for different types of circuits and equipment. Regular inspections and testing of emergency systems are crucial to ensure they will function properly when needed. The NEC requires that emergency systems be inspected and tested periodically to verify that they are in good working order. The inspection should include visual checks of the wiring, connections, and equipment, as well as functional tests of the emergency lighting and power systems. Testing should be done under simulated power outage conditions to verify that the systems can automatically switch over to emergency power and provide the required illumination and power. Any deficiencies found during inspections or testing must be corrected promptly to ensure the reliability of the emergency systems. Compliance with electrical codes is essential for ensuring the safety of buildings and their occupants. Electrical codes are developed by experts in the electrical industry and are based on years of experience and research. They are designed to prevent electrical hazards and ensure that electrical systems are installed and maintained in a safe and reliable manner. Failure to comply with electrical codes can result in fines, penalties, and even legal action. It can also increase the risk of electrical fires, equipment damage, and electrical shock. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date on the latest edition of the NEC and to understand how it applies to specific electrical installations. Many jurisdictions adopt the NEC as their local electrical code, while others may make modifications to the NEC to suit their specific needs. It is also important to follow the manufacturer's instructions for electrical equipment. The manufacturer's instructions provide detailed information on how to install, operate, and maintain the equipment safely. Failure to follow the manufacturer's instructions can void the warranty and increase the risk of equipment failure. In addition to the NEC, there are other standards and guidelines that may apply to electrical installations. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, including NFPA 70E, Standard for Electrical Safety in the Workplace. This standard provides guidance on how to protect workers from electrical hazards in the workplace. The Institute of Electrical and Electronics Engineers, or IEE, also publishes a number of standards related to electrical engineering, including standards for grounding and bonding, power quality, and surge protection. These standards can provide valuable information for designing and installing electrical systems that are safe and reliable. When working on electrical systems, it is important to use the proper tools and equipment. Electrical work requires specialized tools that are designed to protect workers from electrical shock and other hazards. These tools include insulated screwdrivers, pliers, and wire strippers, as well as voltage testers and multimeters. It is important to use only tools that are in good condition and that are rated for the voltage and current levels of the electrical system being worked on. It is also important to wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated footwear. PPE can help to protect workers from electrical shock, burns, and other injuries. Before starting any electrical work, it is important to de-energize the circuit or equipment being worked on. This means turning off the power at the source and verifying that the circuit is de-energized using a voltage tester. It is also important to lock out and tag out the circuit to prevent it from being accidentally re-energized while work is in progress. Lockout/tagout procedures are designed to protect workers from electrical hazards by ensuring that electrical equipment is de-energized and cannot be re-energized until the work is completed. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. If one is not qualified or experienced in electrical work, it is best to hire a qualified electrician to do the work. A qualified electrician has the training, knowledge, and experience to perform electrical work safely and in accordance with electrical codes. In summary, it is generally against electrical code to run 120 volts and 277 volts emergency circuits in the same conduit due to concerns about insulation breakdown, arcing, and induced voltages. The electrical codes, such as the NEC, provide specific guidelines on voltage separation within conduits to ensure safety and prevent electrical failures. Following these guidelines is essential for maintaining the integrity of emergency circuits and protecting building occupants from electrical hazards. Remember to consult the latest edition of the NEC and local regulations to ensure compliance with all applicable requirements. When in doubt, seek guidance from a qualified electrician or electrical inspector to ensure a safe and reliable electrical installation. Additionally, emergency systems should be tested regularly and maintained properly.